Alright, example 2. Given the functions f of x and g of x, find the composite function of m of x is equal to f of g of x. So where f of x is equal to x plus 1 all squared, and g of x is equal to 3x. Now, we can rewrite this in a different form, or you can leave it like this. I'll do this two different ways, and you can see which way you like. So first, I'll write it as m of x is equal to f of, and then we'll change this to g of x. So again, that means the same thing as how this is written. They're both composites. Or we could figure out what g of x is all by itself to start. Now the thing about this one though is we're just looking for a variable to start. So we're not given a constant there. So I'm just going to replace g of x with x. So our x replaces the x, so there's no change. So on our left hand side, this g of x becomes this function 3x. And over here, well, g of x is just equal to 3x. Now on our left side then, f of 3 of x, that means that I am going to replace my x with 3x. So m of x, and we're looking for x, so we've got 3x plus 1 all squared. And then on our right side, it's very similar. So now we're going to take f of g of x. And we know that g of x is 3x. So that 3x again is going to replace whatever term. Now they look very, very similar. Some people just prefer figuring out what g of x here is. Because in our case, x is just staying x, it doesn't matter too much. Now, as far as like expanding this or leaving it in factored form, it really depends on the question. This one doesn't say, so I would probably leave it how it is. Example 3, given the functions f of x and g of x, find the composite function m of x is equal to f of g of x, where f of x is equal to the square root of x minus 3, and g of x is equal to x minus 5. I'm only going to do this one way, so I prefer the method where we just rewrite this, so m of x is equal to f of, and then of g of x. So in our case, x is just being replaced with x, so g of x will stay the same with its x minus 5. So it's going to become f of x minus 5. And now we need to replace our x values in our f function with x minus 5. So it's a square root, and then x becomes x minus 5. I could put brackets here, but there's nothing in front of the x, so it doesn't really matter. And then now I should simplify that as much as I can. So negative 5 minus 3 is minus 8. And that's it, all done. Given f of x, g of x, m of x, and n of x, find each composite function and state the domain. So f of x is equal to square root of x, or we've got g of x, and all of these have been listed for you. Some are reciprocal functions, some are absolute value, some are radicals, and some are just linear. What's a little bit different here though is we actually have 3 different functions. So to make this a little bit easier for myself, I'm going to rewrite this as, so this is g of, and then we have m, and then inside that yet, we have n, and that's going to be n of x. So I'm just going to work from the inside bracket and work my way out. So n of x is x plus 2. So that'll be the first substitution I do. So this becomes m of x plus 2. Now we need to take this x plus 2 and substitute it into the m function. So this is just an absolute value. So it's going to replace that x, and it's going to become the absolute value of x plus 2. Here, our final step in this composite is putting it into the g of x function. So this is 1 over x, so it's going to become 1 over, and this x plus 2 absolute value is going to replace the x. So it's going to be the absolute value of x plus 2. There we go, all done. So this looks a lot worse than it actually is. We do have to do a domain though. So for some things, like our reciprocal function, we can't have it equaling to 0. So here, we're going to have to do x plus 2 absolute value, and that's equal to 0. We're going to figure out what that is. Now there's two ways that there's only one way this could possibly be 0, and it's if whatever's inside the absolute value is actually 0. So we're really just looking for what x plus 2 can make that 0. So I'm going to subtract 2 off of both sides, and I get x is equal to negative 2. Now this absolute value would affect my range, but it's not going to affect my domain. We're just looking for what we can't divide by. Other than that, because it's linear, absolute value, those don't affect our domain. So as long as it's not negative 2, we're good. So x such that x cannot equal negative 2, but otherwise it is a real number. On to our next question. So h of x is equal to n of f of n of x. Okay, so again, I'm going to rewrite this into this form. So I'll have n, and I'll use square brackets this time, and then f of, and then n of x. Now n of x is this x plus 2, so I'll do that substitution first. So we get f of x plus 2. Now this x plus 2 is going to get substituted into f of x, which is the square root of x. So it's going to become n of square root of x plus 2. And then this square root of x plus 2 is going to get substituted into the n function and replace our x. So we're going to be left with the square root of x plus 2. And then outside of the radical, we have this plus 2 still. So that's what our h of x is equal to. Now with a radical, we can't square root a negative. So very similar to the last question, we got to take this x plus 2. And it has to be greater than or equal to 0. So if we subtract 2 from both sides, we get x must be greater than or equal to 0, or sorry, negative 2. And that's going to be our domain. So x such that x is greater than or equal to negative 2, where x is a real number. Our final question of the unit. So example 5, if h of x is equal to f of g of x, determine f of x and g of x. What's a little bit different about this one though is we have a trinomial here. And it does say that more than one answer can exist. So we're going actually the other way. We want to figure out what f of x and g of x is. Well, it looks like it's f of g of x, meaning g of x replaced all the x values of f. So I'm going to assume that this probably x minus 2, x minus 2, they're in both terms. So I would imagine if this was x, and this was x to start, so maybe this originally was like x squared plus x plus 1. Then if I was to substitute in for all the x values, x minus 2, then I would end up in this position right here as a composite. So for me then, I would say g of x is equal to x minus 2. And then this would be my original f of x then. So it'd be x squared plus x plus 1. And actually that's it. Now you might have other ways you can think about that as well. And there is more than one answer here.